All right, so we take a look at the data here. It says, this is question 13 from section 2.4. It says the U.S. Census tracks the percentage of persons 25 years or older who are college graduates. That data for several years is given below. Determine if the trend appears to be linear. If so, and the trend continues, in what year will the percentage exceed 35%? So we're going to have to take this data right here. We're going to have to enter it in our calculator. But I'm going to transform it a little bit because I don't want to have to enter 1990, 1992. I'm going to default this to be year zero. So 1990, I'm just going to replace that with year zero, which means that my equation is going to be in terms of years since 1990. So your -1 would be 89. Your +1 would be your 1991. So your 10 would be, so like that year would be the year 10, right? This would be the year 12. So I'm going to enter all this data into the calculator. So let's see if we can see this. All right, so I'm going to have to zoom back out, and hopefully you've got this worksheet from class today. So I'm going to go in the calculator so we can see everything. Turn it on. We're going to go hit the stat key, and then we're going to hit edit, and then we're going to come over here to list 1 up to the top and hit clear, not delete. Go up to the top of list 2 and hit clear, and now I've got list 1 and list 2. They're ready to go. I just have to enter in all of the years in list 1, so that'll be year 0, year 2, 4, 6, 8, 10, 12, 14, 16, and 18. And then over here in the y values is 21.3, 21.4, 22.2, 23.6, 24.4, 25.6, 26.7, 27.7, 28, and 29.4. Okay, so now we're going to have to take a look at this data, and we're going to do it graphically. So we're going to take a look at a scatter plot. So in this, we're saying, does the data appear to be growing linearly over time, which means our x value is going to be the time axis, and our y value is going to be the percent of people that were college graduates. So I'm going to hit the stat plot button right there. So I'm going to go to stat plot, plot number 1, and I'm going to be pulling list 1 is my x's and list 2 is my y's. So everything's set up here. Don't worry about these other ones for now. We're just doing a scatter plot. So I'm ready to go there, but if I hit graph, I don't see it. The reason I don't see it is because my window's not set appropriately. So I need to adjust the window so that I can see the numbers, right? So I'm going from 0 to 18, so my x values need to go from 0 to 18. But I like to make it a little bit smaller than 0, so I'll go like -1, and my y value, I'll go to 19. So smaller than the smallest and bigger than the biggest. And then for the percentage of college graduates, starts at 21.3 and ends at 29.4. So my y values I might make go from 20 to 30. So again, smaller than the smallest and bigger than the biggest. They don't have to be exactly what I have, just so that I can see everything. And now I'm going to go graph. There's my data. So does this data appear to be somewhat linear? And the answer is, well, it appears to be. So what we're going to do now is we're going to draw a regression line for that. So in order to draw the line of best fit in here, the calculator will do this for us. You hit the stat key, arrow over to calc, and arrow down to linreg. So that's linear regression. That means we're going to make a line. There's a reason why it's called regression. Take my stats class and we'll talk about it. And then ax plus b, right? So mx plus b, it's the slope of the line, and that's the y-intercept. So hit enter on that. And then you have to make sure that it's coming from the right lists. So it's list 1 and list 2. If you have an older calculator where you don't get this window, then you're automatically set up to pull from list 1 and list 2 automatically. You can probably just hit enter. But for this calculator, I've got to tell it list 1 and list 2. And now I'm going to do a little trick here. I'm going to come down here to where it says store regression equation. So what the calculator is going to do is it's going to come up with the line of best fit, but it won't graph it for me unless I tell it to store the equation someplace. So come down here to store reg equation, hit enter. Whoops, I'm sorry. Go back to store reg equation, hit vars, arrow over to y vars, hit enter on function, And now this is where you're going to store the equation as either y1, y2, y3. So I'll just choose y1. Boom. So it's going to store the equation right there, and then we calculate it. So here's the equation of the line of best fit. So it's 0.47 is the slope, and the y-intercept is 20.7. Ignore the r-squared value. You don't care about that for now. The r value is 0.9939. That means the strength of the association is very, very high. So there's a very strong positive correlation between the year and the percentage of people that were graduating. So I can go ahead and graph now, and it automatically prints the equation for me. So I can continue with the rest of the question because it said, if it is linear, which it does appear to be roughly linear, and the trend continues, in what year will the percentage exceed 35%? Well, we know way out here at the maximum, if I trace this, if I go way out here to the last one, that is an actual value of 29.4. If I arrow down and get on the line here, see how I'm on the line out there? So there's a little spider climbing the line. So up here, my predicted y value out there is 29.35. Okay, so here's my actual x, and then this is the predicted y based on the line. So we want to know, when is that value going to be 35? Well, I can't see it here, so I'm going to adjust the window so that I can go a little bit further to the right and a little bit up. So I'm going to let my x maximum be bigger. So I'm going to make it go out to maybe 30, and my y maximum be bigger, make it go out to like 40. So now I'm extrapolating out from the data, right? Because the data only went up to year 18. I'm now making the window go all the way out to year 30. That's called extrapolation. Extrapolation is always dangerous because you're assuming that the trend in the line will continue, that the data will continue to grow in the same rate. And you never know that that's going to occur, but we do this kind of extrapolation all the time. So here's my data, and now I'm extrapolating out here, and we want to know, does it hit 35? So I'm going to graph the line y equal, oh shoot, I just deleted my stuff and I didn't want to do that. So I got to rerun it, but that'll just take a second. Stat, calc, linreg, come down here, vars, yvars, function y1, boom, and it's back. There it is. So I'm going to come down here and type in y equals 35 and graph it. And let's see if they cross. There's the regression line. Here comes y equals 35, and they cross right there. Well, let's see, did they actually cross? Second calc, calc. So yeah, so I hit second and then calc, and I'm going to calc the intersection of those two lines. So I hit enter. So now first curve, so I'm on the blue curve, right? So I hit enter. Then it says second curve, is this the one you want? Yes, so we hit enter. Then it says guess, so just slide over so you're somewhere in the ballpark of where the intersection occurs, and hit enter again. And it occurs at x equals 29.94 and y equals 35. So that point right there is the year 29.94. So what year is that? Well, it's 29.94 years after the year 1990. So that would be, what, 2019.94? So basically the year 2020.